Okay, this is section 3.3 from your MathLinks 9 textbook on exponents. The first question you were assigned for homework was identify the incorrect step in the following solution. Show how to correct it and what is the correct answer. So the question was, in brackets, 3 plus 5 squared minus 4 times 3 squared. So the first thing they did was they simplified the brackets and got 8 and put 8 squared, and then they brought the rest down. So there is no error on step 1. Step 1 is fine. The second step they did is they simplified the first power from 8 squared to 64, and they brought the rest down. So step 2 does not have an arrow, or an error, it's fine. But then in step 3, that's where they made the error. Instead of doing 3 squared first, they did 64 take away 4 first. So at this particular step, what should they have done? They should have done the exponents first, which means that would be their next line, because 3 squared is not 6, it's 9. And after that, it would be multiplication next, which would be 64 take away 36. And 64 take away 36 is 28. So your correct solution would be 28, not 540. In question 4, it says Maria was asked to evaluate 128 times 5 cubed. What mistake did she make? Well, obviously, if we think about bed mass, Maria did her multiplication before she did her exponent. So what she should have done is first did 5 cubed, and her next line should not be this, but 128 times 125, because 5 cubed is 5 times 5 times 5, which is 125. Take your calculator. 128 multiplied by 125 is 16,000. So the correct solution would be 16,000. Question 5, evaluate each expression. Now remember when we talked about this, this is called, in all of these cases here, we can think of these as being numerical coefficients like we did back in grade 7 and 8 when we learned about algebra. So back in grade 7 and 8, you learned that 2x or 3y. 2 and 3 were called coefficients because they were multipliers for the value of the variable. Right? So in these particular expressions, the value of each of these powers is being multiplied by the coefficient outside the bracket. So you first have to simplify the power, and once you do that, you can then multiply it by the coefficient. So with that said, I better bring this down here. Oh, hang on. Where is this at? There we go. So with that said, the first one's going to be 4 multiplied by 2 to the power of 5, which is 2, 4, 8, 16, 32. And 4 times 32 is 128. In my C, I'll just do C first, it's going to be negative 2 times 5 to the exponent of 4. 5 to the exponent of 4 is 25 times 25, which is 625. And 2 times 625 is negative 1,250. In B, you have 7 multiplied by negative 3 squared. Since the negative 3 is in brackets, that's defined as the base. Therefore, it's used in repeated multiplication, and negative 3 squared would be negative 3 times negative 3, which is a positive 9. 7 times 9 is 63. And finally, your last one, D, the coefficient of 3, and then in brackets you have an entire power. Now you need to be aware that this is defining the base and squaring it, which means it's negative 2 times negative 2, which is a positive 4. However, this, the reason why the brackets are there is to separate the coefficient of 3 or the multiplier of 3 from the entire power. So you must treat it as if it was its own entity. You can kind of almost ignore the brackets and say, what does this say? And this says the opposite or the inverse value of 2 squared. Since 2 squared is 4, then its opposite would be negative 4. So my next line is going to be 3 multiplied by negative 4, which is a negative 12. And that's the standard form for that. Your next question, question 6, says write each expression as a coefficient and a power. So here we have the product of 4 multiplied by 2 that's being multiplied by itself 4 times. So the coefficient will be 4, and in brackets, we're going to put 2 as a base and 4, not 2, as the exponent. So when written as a coefficient slash power, we would have 4 multiplied by the value of 2 to the exponent of 4. In my next question, I have 3 multiplied by negative 2 cubed. In the third one, C, I'd have 7 multiplied by 10 to the power of 5. And finally, D, there are 2 ways to write D. You could write it as a negative 1 coefficient multiplied by 9 to the power of 4. You could also write it as a negative 9 to the power of 4. You could also write it as simply negative 9 to the power of 4, or the opposite of 9 to the exponent of 4. All 3 of those solutions would be correct, right? We can think of them all 3 different ways. Even though the 1 is not written here, mathematicians like to think of that negative symbol as being a negative 1, because when you multiply a number by negative 1, you actually get its opposite, right? Question number 7 says, write the key sequence you use to evaluate each expression using your calculator. So if your calculator is not intelligent, it will not know. If you just wrote the keystrokes in 4 times 3 equals and then squared it, you get 144. But if you did the proper keystrokes, you're going to first figure out what is 3 squared, which is 9, and then you're going to take that value and multiply it by 4 to get 36. So the proper keystrokes of this would be 3 as your first one. And if you have an x squared button, you can use it. If you don't, you can multiply it by 2. You could either do that or just put a multiplication and then by 3 again, because 3 multiplied by itself is what 3 squared is. Either pathway you could do. You can either this pathway or this pathway. After that, you can then press the multiplication button, and then you're going to press 4. Same thing here, multiplication, and then 4. So those are your keystrokes to get the answer to the first solution. In your second solution, your keystrokes would be 4. Now there are 2 buttons you can press. If you have an XY button, you're going to press that. And what that does is it defines your base as being 4. And the next button you press will define the exponent, or the y value, 3. So 4xy3 is actually a way to express 4 cubed. If you look at your calculator here, 4, there's my xy button, so I define it as the base. Notice up here, it gives you a little arrow. That's telling you the next number is going to be your exponent. So 3 is going to be your exponent. You press equals, it's 64. So 4xy3, and then an equals button, and then a multiplication button, and then a negative 5. Question 8, evaluate. So in BEDMAS, I'm going to do my exponents first. 3 squared is 9. Do both of those first. 9 plus 9 is 18. In my next line, I'm going to do my brackets first, which is 2 plus 7. So I'm going to have 9 squared minus 11, which will become 81 minus 11, which is going to have a final answer of 70. And I am aware I'm doing this linearly, and I always want you to do it vertically. But don't worry about it. I just have lack of space here. In the next one, we have 2 powers. We have, and I'll highlight them for you, if I can get my highlighter up here. I have this power, and I have this power. So what I'm going to do in my first step is simplify both of those powers. 7 cubed is 49 times 7, which is what is it? 343, thank you. 343 minus 3 multiplied by negative 4 cubed, which is negative 64. So by simplifying just the powers, I get this new BEDMAS question of 343 take away 3 times negative 64. Do my multiplication next, which will be 343 take away 180, 192, take away negative 192. Right? Make sure that this is a subtraction symbol. It's still a subtraction symbol. And the product of these two is a negative. So because that works the way it does, the subtraction symbol stays subtraction. The product of 3 and negative 64 is negative. I need brackets. But of course, at this stage, most people do not enjoy subtracting negatives, but rather adding the opposite. And in which case, I'd have 343 plus 192, which my brain cannot comprehend right now, plus 192 equals 535. And finally, your last one, I can actually do vertically because I have room. So I'm going to do my powers first. So again, if you want me to highlight them, I would. There's one power I'm going to simplify and another power. So 9 plus the simplified power of negative 2 cubed is negative 8. Take away 2 bracket. Now look here. This is not the same thing as this. It is the same thing as this. The reason why there's brackets around it is because it is attaching itself to a coefficient of 2. And without the brackets, it would be 2 minus 6 squared, which is not the same thing. We wanted to say 2 multiplied by the opposite of 6 squared. And the opposite of 6 squared is going to be a negative 36. So when we simplify those two powers, that's our next statement. I have an addition. If I highlight my operations that are left, I have an addition, I have a subtraction, I have a multiplication. I'll do my multiplication first. So 9 plus negative 8, take away negative 72. Now I simply have addition, subtraction. I'll just solve them from left to right. 9 plus negative 8 is 1. And 1 take away negative 72. If you take away negativity, you make it more positive. How much more positive? 72 more positives, which makes your final answer 73. Our next question says find the value of each expression. Same thing. I'm going to do 7 take away 2 multiplied by 9, which will become 7 take away 18, which will become negative 11. 7 take away 18 is negative 11. In the next question, actually, hang on a second. There, I just erased the bottom part. Isn't that clever? So now I can do it vertically instead of horizontally. So I have brackets and I have exponents. So I'm going to do my brackets first. Negative 4 take away 3. If I take away 3, I'm making it more negative. If it started at negative 4, it's now at negative 7. So negative 7 is the simplification of negative 4 take away 3. I'm simply going to bring down the rest of it. I now have two powers. Negative 7 squared with the exponent outside. The base is negative 7, so therefore it's a positive 49 plus a positive 9. And 49 plus 9 is 58. So the solution to B is 58. C is a power divided by another power. Now, some people think they can use the rule of keep the base and subtract the exponents because we are dealing with two powers. But the power, that rule, that law, only applies when the bases are the same. And these two bases are completely different, so that law does not work. So we're just going to simplify this down to two standard forms. Negative 2 to the power of 6. If Donovan was here right now, he would tell you that a negative base to an even exponent will always be a positive answer. And 2 to the exponent of 6 is 64. Is that right? 2, 4, 8, 16, 32, 64. So it's a positive 64 divided by 4 to the 3, which is also 64. Now, if you are weak with the math game and your arithmetic is not as strong as it should be, 64 divided by 64 is not 0. It is 1. So your final solution for C is 1. And finally, your last question, question 9, gives you this long expression. This is kind of interesting because there are brackets here, and inside those brackets there are powers. So we have to simplify the exponents within the brackets and then subtract them. So I'm not going to write down the rest of the line yet. I'm simply going to simplify this into 49 take away 25 and get my answer of 24. I'm going to keep that in brackets, and then I'm going to bring down the rest. And I don't really need brackets around 24. I'm just going to put plus 24. So 24 take away 2 squared plus 24. That's interesting. 24 take away 4 plus 24 will be 20 plus 24, which will be 44. For question 10, it says, for each pair of expressions, which one has the greater value? How much greater is it? So there's two parts to it. Which one's greater and how much greater is it? So I'm going to simplify both of these. This is going to be 3 multiplied by 2 cubed, which is 8, which has a standard form, I'll write in red ink, of 24. The other one will be 2 multiplied by 3 squared, which is 9, which has a standard form of 18. Which one is greater? 24 is greater. How much greater is it? It is 6 greater. 6 greater. If you are hearing side conversations, it's the two old guys from the Muppet Show that are currently making comments consistently throughout the entire video. The next one, we have 3 times 4 in brackets, which is 12. Now, you could have applied law number 3 here, because law number 3 says when you have the product of two numbers to an exponent, you may distribute your exponent to both of them. So we could, instead of doing 12 squared, which I think I would do anyway, to get 144, technically, if you wanted to use that law, you can get 3 squared times 4 squared, or 9 times 16, which is still going to be, no matter how you look at it, 144. So this expression, the whole thing, will simplify down to 144. And over here, we're going to get 9 times 16, which we just did, which is 144. So these two are not greater than each other, they are equal. And finally, your last one, 6 cubed plus 6 cubed. Well, 6 cubed, if I take my calculator and use 6, now I could either do 6 times 6 times 6 and get 216, or I can do 6xy3 to get 216, or on some calculators, I think this one might have it, yep. If I go 6 and then press the up button, I can actually create an x cubed button. It'll cube my number for me to get 216. So either way you do it, you get 216 plus 216, which is 432. Over here, some people think that you can apply the same law that you did with b. You can apply the exponent of 3 to both of these, but it does not work for sum or difference, just product and quotient. So here we actually have to take our 12 and cube it. And if I take my 12, I can do that cube button right there. I get 1,728 when I cube it. So which one is bigger? This expression is bigger. How much bigger is the difference, or the subtraction, of 1728, take away the lesser amount of 432, and the difference between them, it is 1,296 bigger or more. Question 17, in great big giant letters, says, what is the value of 5 cubed squared? Now, a brilliant guy said, is this what it means? Is this the same thing? And the answer is no, it's not the same thing. What this is asking you is, what is this exponent really as a number? If I want to think about what does that exponent really say, that exponent is really the number 9. So this is really equal to 5 to the exponent of 9, right? Because 3 squared is 9, so really this question is, what is the value of 5 to the exponent of 9? So if I take my 5, use that beautiful XY button, and define the exponent as 9, it will tell me, in standard form, 1,953,125. And your last question says, use 4 2's to write an expression with the greatest possible value. So somebody came in and they did this one, 222 squared. Okay, so if I take that one and I go, where's my thing? So 222 squared, so 222 xy2, I get a standard form of 49,284. What's a better idea for exponent relationship? Before we get to the other ones, let's say another one you might have chosen was this one, correct? So if we choose 22 to the exponent of 22, so 22 xy 22, we get, wow. So I'm going to write this in scientific notation just to show you. I'm going to say it's approximately 3.4, and we got each time so times 10, 20, 10, 100,000, 10, 100,000, so 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, times 10 to the power of 29. So when I get that, I get a number with 29 zeros. But believe it or not, that is not even close to the largest number. The largest one I believe you can get is 2 to the exponent of 222. And if we plug that into the calculator without it breaking on us, 2xy222, we get this number here. Now what this says 6.73, and then we have this e. That e stands for an exponent of 10 to the power of 66, which means I would have to move that decimal 66 places to the right to get the number. So this would be 6.7 approximately equal to times 10. What was our exponent again? 66, which is one freaking big number.